Having seen shortest jobs first, let's take a look at a variant of the algorithm, specifically what I call shortest jobs first live. The algorithm we talked about before, right, just plain shortest jobs first was kind of an offline algorithm, right? So it wasn't that useful for us. So here, right, here's basically the thought. I know they have a bunch of processes running. I know they're going to be requesting CPU time at some point in the future, but because I'm live, right, I don't know those in advance. So instead, guess them, right? Guess them based on some sort of a track record. So this process has made this request in the past, so in the future it'll probably make this request as well. Can we simulate that, right? And then from that, basically choose what it is that we want to run next. So we'll introduce a little bit of notation here. First of all, I have tau sub n. What that's representing is a guess for CPU time, right? So somehow, right, your program is running, right? I should say your operating system is running. It's basically at some time, time n, right? And it wants to know how to schedule things, for time n plus 1, right? It wants to know about the future. The problem is that for time n plus 1, well, that hasn't happened yet. I don't know what the processes are going to do, right? I'm in a live scenario. And so what I'm going to do instead, right, because I don't know exactly what's going to happen, is I'm going to estimate, right? Based on what these processes did in the past, I'm going to estimate, right? And that's what I'll call my tau value, right? So my tau sub n basically represents the guess for how large a CPU burst will be in the next kind of time step, right? When the next time the process requests something, how much will it request, right? That's what I'm kind of guessing here. My other notation here, right, is t sub n. Right, so t sub n is the actual time the process needs, right? So that's basically what we've had in the previous examples, right? We were like, okay, this process needs this amount of time, this amount of time, this amount of time. We knew that all in advance. Here what we're saying, right, is that this is my notation, right, to indicate that, right, versus my tau is my guess. So I have two things here, right? Actual CPU time versus estimated CPU time. And so the goal is, right, is that we know basically t sub n, right, for the past, right? Those are the things we've seen in a live algorithm, but we don't know them for the future. So based on those t sub n, we want to estimate our tau sub n. And then our tau sub n, assuming we have, a bunch of processes running in parallel, right? All of them will have basically a tau sub n, right? They'll have, the estimate for how much CPU time they'll want next time they run. Using that tau value, we can do our shortest jobs first, right? So we can order those based on those tau values and then run them in that order, right? And we don't really know how long it's going to take, but we've guesstimated, and hopefully what we'll do, right, is we'll have kind of the same effect as if we were to run shortest jobs first, right? Hopefully that algorithm will request what we think it's going to request. Our mechanism here will be to calculate tau sub n as kind of a linear combination of the t sub n's. So we have a kind of a formula here, right? There's this formula, and we'll go through that in a second. There's also this little note here, right? Alpha between 0 and 1. What alpha is basically a weighting factor. Because if I'm trying to guess how long a process will take, tau n, my guess can come from two places. It can basically come from my kind of immediate history, my t sub n, right, that just happened, or I can take it from my tau sub n, right? So kind of the tau sub n is kind of my old estimate, right? So what happened versus what I thought was going to happen, right? I have kind of those two things going on, right? I'm kind of a little bit after this thing has actually happened, right? I'm kind of estimating from the most recent past, right? And so I can look at the past and see what happened versus what I think happened. And I can weight those, right? So that's what alpha is doing, right? Alpha is basically weighting between, do I trust, my previous guess, or do I trust what just immediately happened? Note that you don't want to do something like tau sub n plus 1 equal, t sub n. Basically what that would say is my current guess is just what happened last time. Because what happens is somehow the algorithm gets stuck, right? It's always going to do the same thing. And we don't want that. We want basically to adjust and follow the program's burst request. Because over time, programs typically have this pattern, right? They make a lot of requests and they go down, right? Make a lot of requests and go down. We don't want to get stuck in a thinking it's always going to make requests, or always not going to make requests. We don't want to be stuck in those positions. We want to basically track what it is it's doing. And we'll kind of see that in detail when we look at the image on the right-hand side. But just wait a second before that. So getting over here to our formula. Our formula says tau sub n plus 1 equal alpha t sub n plus 1 minus alpha times tau sub n. So here, right, you can see where you have this linear combination, right? So it's a little bit of tn, a little bit of tau n, right? The mix is kind of controlled by alpha. Typically, this value is a 0.5, right? The higher that value is, the more you're weighting the last thing you saw. The lower it is, right, the more you're weighting your tau sub n, right, your last guess. Usually we just blend them together, though, 50-50. So my tau sub n, right, here what I'm saying, right, is that my estimate is, half of what I last saw last time, right, 0.5 times t sub n, plus half of what I saw, or half of what I guessed last time. So that's basically the way my formula is set up. Jumping over here, right, to the picture, right, what this picture is showing is basically my t sub n's and my tau sub n's. So here, right, my blue line, right, this is my tau, right, so this is my estimate, right, blue is an estimate. The black is, the actual values that I saw. And so let's try reading this, right? Maybe we'll jump back to the formula too. Initially, we can see that our tau started off at 10. So that was kind of my guess, right? My system, when I first started running it, needs to start with some initial guess, starts here with a 10. And then in that time step, right, what happens is, oh, my 6 over here, right, that's kind of how long it actually took, right? So my process clearly took less than it actually thought it would. And at the beginning of the day, right, you kind of have no choice but to guess your tau sub ends, right? You have to start with some initial value. But then once you start seeing data, hopefully you can update it. And you can see here, right, that as time goes on, it does update, right? You can notice that somehow my blue little line there, right, is going down. What that's representing is that I have kind of a new tau, right? Next time around, my tau is a value 8, and my process again uses 6, right? So somehow the delta there is shrinking, right? Instead of being, my estimate being off by 4, now it's off by 2. So let's actually see, how we compute that, right? So here we said this is kind of my initial guess, right? And that's kind of arbitrary. And then what this little formula here is meant to do is basically predict this over here, right? What is kind of be my next kind of runtime. And so if I were to plug in my values, what I get is something like this. I get, my actual time was 6, right? So I have basically my 0.5 times 6 plus over here this becomes 0.5 times 10. Well, 3 plus 5, that's going to equal 8, right? So that's me using these 2 points here, right? So this over here, this 6, right, kind of maps over here. This 10 maps over here, right? Those are my 2 values there. And I'm using them together to estimate this tau over here, right? That's my goal. And so that estimated tau, right, that's basically going to be how I sort this thing. So if I'm running short jobs first, I'm going to compute the tau for all the processes that are out there, right? I'll get this estimated runtime, right, this tau sub t, and then I can sort them by how long they are, right, and then let them run. As my program continues to run, right, I see more stuff, right, and I maybe have to update my prediction. So let's say over here, right, I go to kind of the next cycle. Maybe I want to predict this thing here. Well, if I want to predict that one over there, well, basically what I need to do is look at the past 2 points. So in this case, right, my past 2 become, this estimate over here, and then that one over there, the actual runtime was still 6. And so then in that case, it gets something like this, right? This will probably be, 0.5 times 6 plus 0.5 times 8, right? Which gives me then 7. So you can see that I'm basically going down a little bit. I know that the numbers don't quite match up. Somehow on the graph, right, it's like we have to kind of this fight, right, between discrete values and not discrete values. So the 7, I suppose, is really it's really happening here, right? That's kind of, this is, somehow your little, it's almost like a tick, right? Here we're drawing it as if it's continuous, right? But maybe it's unfair to treat it as continuous. Our 7's happening there, right? That's kind of our little midpoint. And we can continue doing this, right? We can continue estimating these, continue estimating these. The point is, right, we generate for every process that's out there a tau sub n to see, how much I think it's going to run next time, and then based on that, do short jobs first. The hope is, right, that my little tracking thing here, right, will basically follow what the process is going to do. So here, right, you can see the process was like kind of a little bit, not requiring that much, and then it jumped up. And you can see that, roughly speaking, right, our little blue curve here, right, which is, trying to estimate, right, is roughly matching the shape of that. So yeah, it's kind of like a moving average, right? Moving average to predict how much time will take. If you want, right, there's some individual values here, right? You can work these out by hand. So yeah, that's short size first. Now the live component.